Lesson 3-1. Solve the equation x squared minus 2 equals 7 using the indicated method. First, it wants you to solve by graphing. Okay, so let's graph it with our calculator. X squared minus 2, so that's going to be x squared minus 2. And then our other one is 7. So we'll press tab, 7, enter, and I don't see it. It's up here. Okay, so we need to find this point here and that point there. Menu, 6, 4, and we'll highlight that point. And menu, 6, 4, and we'll highlight this point. So we got negative 3, 7, and 3, 7. This is negative 2 here, so that gives us some points to graph. And let's see. Negative 2 is right here. And then negative 3, 7 is right there. And positive 3, 7 is right there. And we're going to have, it's going to look something like this right here. And there's our graph of the x squared minus 2 part. And the equal 7 part here. That's not right. So these 2 points right here where they cross, and that is 3, 7, and this is negative 3, 7. So solve by graphing, we got x equals negative 3, and x equals 3. Part B, solve by factoring. So we have x squared minus 2 equals 7. We need to get everything on the left side, so minus 7 from both sides. And we got x squared minus 9 equals 0. Now we need to factor this. Okay, what are the factors of 9 that would give you 0x? And that would be 3 and negative 3. So we've got x minus 3 times x plus 3 equals 0. So x minus 3 equals 0. And then x plus 3 equals 0. Add 3 to both sides, you got x equals 3. Subtract 3 from both sides, you got x equals negative 3. Okay, notice we got the same answer both ways. And then right here, same answer. Okay, good. Now it says C, solve by taking square roots. So we let's do that. We've got x squared minus 2 equals 7. So let's add 2 to both sides. And we got x squared equals 9. And then we'll take the square root of both sides. And we get x equals plus or minus 3. So x equals 3 and x equals negative 3. Got the same answer all three ways. Now, if you're having a problem, factoring, we've got this right here. Okay, you can get it equal to 0, then you can go to your calculator and menu 3, 3, 1. The degree is 2, real roots, and then let's see here. Notice this is like a 1. So we got 1 here. And we don't have a middle term, no middle term. That's like x squared, 1x squared plus 0x minus 9 equals 0. So we don't have a middle term, so we'll put a 0 in there. And then the last term is negative 9. Press enter. Check it, x squared minus 9, that's what we had. Press enter. It gives you negative 3 and 3. So that's like 4 different ways right there. 1, 2, 3, and this would be the 4th way. That's not wanting to move. Let's try number 2. It says solve the equation 2x squared plus 3 equals 5 using the indicated method. Solve by graphing. Let's try a graphing calculator again. If you don't have a graphing calculator at home, you can go to, if you don't have a graphing calculator at home, I'll show you one real quick. We'll go here. Type in Desmos. Desmos. Let it search. Graphing calculator. And then you can type in your equation. 2x let's see here. Show keypad. 2x squared, and then what was it? Plus 3. Yeah, 2x squared plus 3, and put a you can add another line. What was the other number? 5. Yeah, 5. Maybe we need to put y equals 5. Y equals 5. And that put it in there. And then you can find that spot, negative 1 and then positive 1. So that's another way to do it. There it goes. Solve the equation 2x plus 3. And since we already did it, we did it on Desmos. We had some points. 3 here. And what were those points? 1, 2, 3. Yep. And then -1, 5, and 1, 5. -1, 5, 1, 5. And then we'll try to give it a nice rounded thing there. And there it is. It's -1, 5, and this is 1, 5. So x equals -1, x equals +1. We have b, 2x squared plus 3 equals 5. Let's subtract 5 from both sides. We get 2x squared minus 2 equals 0. And then we're going to divide both sides by 2. We get x squared minus 1 equals 0. And then we can factor this. Notice we got a difference of perfect squares, x squared and 1. So we're going to have 2 times x minus 1, and then 2, or x plus 1 equals 0. So x minus 1 equals 0. X plus 1 equals 0. Add 1 to both sides, you got x equals 1. Subtract 1 from both sides, you got x equals -1, which is what we had here. Notice they're the same. Solve by taking square roots. 2x squared plus 3 equals 5. Subtract 3 from both sides. You got 2x squared equals 2. Divide both sides by 2. You got x squared equals 1. Take the square root of both sides. And you have x equals plus or minus 1. So x equals 1, x equals -1. Again, you got the same answers all 3 ways. Let's try number 3. It says, solve the quadratic equation by taking square roots. This is a nice, easy way. Divide both sides by 4, and you got x squared equals 6. Take the square root of both sides, and you have x equals plus or minus the square root of 6. If we do it in our calculator, menu 331, degree is 2, real. You've got 4 here. You have no middle term, 0. And if you notice, this is on the right side, so you're going to have to move it. 4x squared equals 24. You got to subtract 24 from both sides. And that gives you 4x squared minus 24 equals 0. Okay, you got to get it where 0, because that's what you're telling with the menu 331. You're telling the calculator you're wanting to find the zeros. So let's go in here and we put -24 in there. Enter. And then we press enter. And it gives you -2.449. And just so happens, that happens to be the square root of 6. Okay? And yes, you can graph it as well. Tab on new document, no, graph, and you got 4x squared and tab 24 and menu 4, 4. So zoom, there it is. Menu 6, 4. Menu 6, 4. And 2.45 and negative 2.45. Okay, so you can still do it all three ways. What about here? We're going to take the square root. So let's subtract 15 from both sides. And we've got negative x squared over 5 equals negative 15. We're going to multiply both sides by negative 5. Negative 5 times, and then negative 5. That's going to give us x squared equals 5, that's 25, put it 2, 5, that's going to be 75. Take the square root of both sides, and we get x equals plus or minus the square root of 75. Now, 75 has a perfect square in it. I'll show you. The square root of 75 equals the square root of 25 times 3. And 25 is a perfect square. So we got the square root of 25 times the square root of 3. And that's going to equal 5 times the square root of 3. So x equals plus or minus 5 times the square root of 3. And let me show you in the calculator. We have the square root of 75. And that gives you 8.66. Now let's do 5 times the square root of 3. 8.6. They are the same. This 5 times the square root of 3 is simplified. The same concept, perhaps you had something like 2/4, right? You would know to reduce that to 1/2, okay? That makes it easier to understand. The square root of 75 equals 5 times the square root of 3. This makes it easier to understand. You might not necessarily agree with that right now, but if you worked with them more, you would. Let's try number 5. Okay, so we got 2 times. We would need to first divide both sides by 2. And that gives you 5 minus 5x squared equals 5/2. Well, let's subtract 5 from both sides. And that gives you negative 5x squared equals, that's a tough one. So we got 5/2 minus 5. Okay, and that's because 5 is 10/2, right? So we got negative 5/2. Negative 5/2. Well, let's divide both sides by negative 5. Okay, and that gives us x squared equals, so we got negative 5. Let's divide by negative 5. And that gives us 1/2. Equals 1/2. Now let's take the square root of both sides. And that gives us x equals plus or minus the square root of 1 over the square root of 2. Now we're not allowed to have we're not allowed to have a radical in the denominator. So we're going to multiply the top and the bottom. This is called rationalizing the denominator. And that's going to give us the square root of 2. 1 times 2 is 2. And the square root of 2 times the square root of 2 is the square root of 4. Well, the square root of 4 is the same thing as 2. Okay? So x equals plus or minus the square root of 2 over 2. Let's try number 6. We add 8 to both sides. And we get 3x squared equals 20. Divide both sides by 3. And you get x squared equals 20 over 3. Now let's take the square root of both sides. And it gives you x equals plus or minus the square root of 20 over the square root of 3. Now the square root of 20 is the same thing as the square root of 4 times 5. And that's the square root of 4 times the square root of 5. And the square root of 4 is 2. So we got 2 times the square root of 5. So this is going to x equals plus or minus 2 times the square root of 5 over the square root of 3. Again, we can't have a radical in the denominator, so we got to rationalize it. We'll multiply the top and the bottom by the square root of 3. So x equals plus or minus 2 times the square root of 15 over the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. Good job. Number 7, write and solve an equation to answer the question. Give the exact answer. If it's irrational, a decimal approximation to the nearest tenth of a second. A squirrel in a tree drops an acorn. How long does it take the acorn to fall 20 feet? All right, so we got to have us a tree. Let's see here. Got to have us a tree. And then it's got a branch in that tree, and it's got a little squirrel sitting on it. I know I'm not a very good artist. So there's the branch, and there's leaves or whatnot. I need my artist. All right, so we're going to say that from here to the ground here, that is 20 feet. Okay, and there's a little acorn. There's a little acorn. That seems to be a big acorn, and it's going to fall 20 feet. How long does it take the acorn to fall 20 feet? If you look back in your notes from the thing, it gave you d of t equals 16t squared. And that's gravity. It doesn't take into account anything other than just gravity. Well, we also know that the distance is 20 feet. So we can set these equal to each other. 16t squared equals 20. If we divide both sides by 16, we get t squared equals 4 goes into 20 5 times, and 4 goes into 16 4 times. Take the square root of both sides, and we got t equals plus or minus the square root of 5 over the square root of 4. Well, the square root of 4 is 2, so we have the square root of 5 over 2. Now, we're going to reject the negative because you can't have negative time. Negative time is unreasonable. The square root of 5 divided by 2, we can check with our calculator. Control square root, and the square root of 5 over 2, over 2 is approximately 1.118 seconds. So that's going to be an approximation of 1.1 seconds. So when that squirrel drops that acorn, you have 1.1 seconds to get your head out the way, or you're going to get a knot. Let's try number 8. What does it say? A person washing windows of an office building drops a squeegee from a height of 60 feet. How long does it take the squeegee to pass by another window washer working at a height of 20 feet? I think we need us a building. All right. And with the building, well, they're washing windows, so we need some windows. All right. And let's get us some windows. Some of them are a little bit bigger than others. All right. Okay. So we got a window washer here, right there, and he is washing this window here, and he's got a squeegee in his hand. And then we've got another window washer, and he's got a squeegee, and he's washing this one, and he's going to drop it, and it's going to go like this because he just accidentally dropped it. I know it kind of looks like he might have thrown it, but that's not what the problem says. So how long does it take? And we'll say this guy here is at 20 feet, and this up here is at 60 feet. So how long does it take? How long does it take? All right, what if you have, let's see here. We'll say f of x, well, h of t. H of t is some height minus 16t squared. That's based off of that other one. And then okay, so what do we got? We've got, how do we fill this in? We've got 20 equals 60 minus 16t squared. So we subtract 60 from both sides. And that's going to, we subtract this, so that's going to give you negative 40 equals negative 16t squared. Divide both sides by negative 16. And we're going to have, well, the negatives are going to cancel out. So we've got 40 over 6. Whoa, that's going to, 4 goes into that 10 times and goes into this 4 times equals t squared. Now let's take the square root of both sides. And we're going to get the square root of 10 over the square root of 4 equals t. And I'm curious, did I? Yes, I did make that t. All right. The square root, and again, that's plus or minus, but since we're talking about time, we're going to get rid of the minus. So we have the square root of 10, and the square root of 4 is 2, and that's going to equal t. Well, how much is that? .58 seconds, which is approximately 1.58 seconds. So that's how fast, Tori, you got to move before Sydney pops you on the head with that. But he wouldn't do that. It would be an accident. He wouldn't do that on purpose. Determine the lengths of the sides of the rectangle using the given area. Give answers both exactly and approximately. All right. The area of the rectangle is 45 centimeters squared. All right. So area is length times width. We know that. We've been taught that. So if the area is 45 centimeters, and what do we got? We've got x, so we got x times 3x, right? That's length times width. What happens here is some people will make that 4x, and it's really supposed to be 3x squared. Now we can solve it. Divide both sides by 3, and you get 15 equals x squared. We're going to take the square root of both sides, and we get plus or minus the square root of 15 equals x. Can we have a negative? We can't have a negative area. It has to be 0 or larger. So we'll get rid of the negative. We'll get rid of the negative. So our answer is x equals the square root of 15, which is approximately, what's the square root of 15? 3.87. 3.87. So if this is the square root of 15, this is 3 times the square root of 15. And I wonder, so 3.87 times, and then you got 3 times 3.87. See how close that gets. You got, we'll just go up there and grab it, times 3 times and 45. It worked out. Good. What about number 10? What about number 10? The area of the rectangle is 54 centimeters. I'll move this up a little bit. And what do we got? So we got same thing as before. 54 equals x times 3x. So 54 equals 3x squared. Divide both sides by 3, and I'm on 54 divide 3, 27, no, 18. All right, so we got 18 equals x squared. We can take the square root of both sides, and that gives us, well, hold a second, the square root of 18, that's like the square root of 9 times 2, which is the square root of 9 times the square root of 2. So I'm getting 3 times the square root of 2. All right. So we have plus or minus 3 times the square root of 2 equals x. Again, you can't have a negative here. So, and then 3 times the square root of 2, 3 times the square root of 2 is approximately 4.24. Is approximately 4.24. Find the square of the imaginary number. We haven't talked about these yet, and you're going to love them. They are great. We have, and put this in your notes, I is equals the square root of -1. So I squared equals -1. So find the square of the imaginary number. So let's square it. And that's going to give you 9 times I squared, 9I squared, which is -9, because I squared is -1. And we can try that in our calculator. 3, now you don't want to use this I in here. You want to press the pi button, and you got the number I. All right. Now, let's see here. Open parentheses and grab that. Close parentheses squared. and that gives you negative 9, which is what we got here. What about this? What if we square this? That gives you I squared times, and that's the square root of 5 squared. Well, what's the square root of 5 squared? That's going to be 5. And then this is negative 1 times 5, so you have negative 5. Let's try that. Open parentheses, the number I times the square root of 5. What did I do wrong? I didn't square it. Negative 5. And there we go. Well, what if we square this? Let's try that. Open parentheses. And then what do we got? Negative I times, and then we got the square root of 2 over 2. And then I'm going to go ahead and square this first so I don't make a mistake there. You got negative 1/2 equals negative 1/2. Pretty cool, huh? This number here, I, allows us to solve radicals. You know, before we had like negative 25, we had to say no real solution, which that is true, but now we can take it, the negative 25, and make it the square root of negative 1 times the square root of 25, and that gives us I times 5, or 5I. Okay? So it allows us to solve those when we used to couldn't. Number 14, determine whether the quadratic equation has real solutions or imaginary solutions by solving the equation. So first, we're going to add 10 to both sides, and that gives us 15x squared equals 10. We're going to divide both sides by 15, and that gives us x squared equals 5. That would be 2/3. We take the square root, and we got x equals plus or minus the square root of 2 over the square root of 3. Now we got to rationalize it. So we got the square root of 3 over square root of 3. So x equals plus or minus 2 times 3. That would give you the square root of 6. And the square root of 3 times the square root of 3 is the square root of 9, which is 3. So determine whether the equation has real solutions or imaginary solutions. This has 2 real solutions. All right. Now, I'm going to show you a calculator shortcut. We go to our calculator, menu, 331, degrees 2, real, press enter. What do we got? We got 15 in front of the x squared. We don't have an x, so we put a 0 there. And then, was it 10 or negative 10? Negative 10. We put a negative 10 here for the constant. Press enter. Aha, see, no i's, real solutions. And let's go over here. What if we subtract 12 from both sides? And that gives us 1/2 x squared equals, and that would be negative 8. Multiply both sides by 2. And that's going to give us x squared equals negative 16. Take the square root of both sides, and that gives us x equals plus or minus the square root of negative 16. Before, you used to have to say no real solution, but now we know the square root of negative 16 equals the square root of negative 1 times 16. So that's the square root of negative 1 times the square root of 16. The square root of -1 is I, and the square root of 16 is 4, or 4i. So x equals plus or minus 4i. And we would say this has two imaginary, I didn't spell that very well, did I? Two imaginary solutions. Uh-oh, 16. All right, folks, I believe this is going to be our last one. So we got to distribute that. We've got 10x squared minus 15 equals, and that's going to be 4x squared minus 40. If we subtract 4x squared from both sides, and that's going to give us 6x squared minus 15 equals negative 40. We're going to add 15 to both sides. And that's going to give us, wait for it, 6x squared equals negative 25. All right, I need some real estate here, so I'm going to have to, that's going to be too much. There we go. Divide both sides by 6, and we've got x squared equals negative 25 over 6. We're going to take the square root of both sides. Wait for it. Gives you x equals plus or minus. Now, let's take this over to the side here. That gives you the square root of negative 25 over the square root of 6. All right, and we know that's the square root. The square root of negative 25 equals the square root of negative 1 times 25, which is 5i. So we have 5i over the square root of 6. We can't have that on the bottom. So this is going to give us 5i times the square root of 6 over the square root of 6 times the square root of 6 is the square root of 36, which equals 6 over 6. So there is our solution, and this gives us two imaginary solutions. To imagine, I'm not spelling imaginary very well, am I? To imaginary solutions. Good job, folks. I will see you in class. You have a great day.